Hey guys, so I'm just doing a quick review with you in regards to what we've been learning so far. We've been focusing on circular vertical paths. Vertical being, focusing on when the object is at the bottom and when the object is at the top. We were able to dive into our new equations for this week in order to find apparent weight. Reminder that apparent weight is the feeling of heaviness and lightness when it comes down to where you are going, right? If you're going above or below or down a hill and up a hill. So when the object is at the top of a hill or at the top of a circular path, we then say that acceleration is moving in the downward direction because remember, acceleration is moving towards centripetal force. And the centripetal force is located in the center of that circular path. This is when we then say the equation for apparent weight becomes negative because acceleration, which is v squared over r, that's how we discover it, is moving in the downward direction. When the acceleration is moving towards the centripetal force and the object is at the bottom of the circle, that is when we say that the equation now it is positive because acceleration is moving at the positive direction. So the two equations that we have is Fn equals m times g plus or minus, depending on the direction of acceleration, v squared over r. And when we want to find velocity, the equation that we use is v equals the square root of gravity, which we now discovered is 9.8 times whatever the radius is for that circular path. So let's kind of apply that, right? So we are looking at this problem and we understood that we have mass, we have radius, and we have speed. So that means mass is 2.5, radius is 0.80, and velocity, which we say is a cousin of speed, be that velocity has direction and speed does not, is 3.5. Based on the question, we are trying to figure out what that tension is going to be at the bottom, when that bucket is at the bottom. And that's important. The location is important because that's how we're able to discover if we're using the positive or the negative side of that equation. And like we learned, if it's at the top, acceleration is pointing downwards, therefore it's negative. If it's at the bottom, acceleration is pointing upwards, therefore it's positive, right? So because it's at the bottom, we're looking at acceleration pointing positive. So our equation is going to be written Fn equals mass times gravity plus v squared over r. Now we can take our details and replace it with the variable that we have. We don't know what normal force is. That's what we're looking for. We have mass, which is 2.5. We have gravity, which we're aware of, that is 9.8. We have velocity, which is 3.5 squared divided by radius, which is 0.80. Your first step would be to focus on that velocity because that's double the work. Before you can divide anything, you want to make sure everything is simplified. Velocity, which is 3.5 times 3.5, gives you 12.25. You're going to divide that by 0.80, as seen here. So then you get 15.31. Then you're going to add it to 9.8, which gives you the accumulation of 25.11. So 3.5 squared give you 12.25. You divided that with radius to get 15.31, then you added it to get 25.11. The last step will be to multiply it by the mass. So you have 2.5 times 25.11, which gives you 62.7. So your answer in this moment becomes B. In this problem here, it's similar to the one we just did. The only difference is now the bucket is on top. And being that the bucket is on top, We now understand that if the object is located on the top of the circular path, we're now working with the negative symbol. So all this will still remain the same except for the symbol in the middle, which will now go from positive to negative. So now you're going to still work your way through everything. Now the only difference is you are subtracting gravity with whatever you got from velocity squared over r, which is 15. When you subtract these two, you now will have 5.51. Multiply the 5.51 with 2.5, and you now have 13.77, which rounds up to C being your answer. Now this problem is a little different. Although you have similar components, like details, from the previous two questions, this one is a little different because if you notice the question, you're no longer looking for apparent weight or normal force. You're looking for the minimum necessary velocity. So in this moment, this is where that third equation comes in that looks like this. V equals the square root of gravity times radius. Where we now know that gravity is, again, we're aware that it is 9.8, and we understand that the radius, according to this problem, is 0.80. So now you can say, what is 9.8 times 0.80? And that gives you the square root, because we haven't gotten to the square root yet, of 7.84. And when you square root that, velocity gives you 2.8. Therefore, your answer here becomes A. Please make sure you use this video to support you for what we're going to be learning this week.